This is day 12 of coding every day until I hit 1K subs. Usually I spend my downtime, like when I'm at the gym or on the train, scrolling through Instagram Reels. It's a huge time sink, and I've been trying to quit, but I needed something to replace it with. That's when I remembered I can actually code on my phone using GitHub Codespaces. Here's a quick look at Codespaces on my phone. The problem is, the on-screen keyboard is really difficult to use for coding, and Klein, which would be ideal, is too expensive for me right now. So I came up with something else. My VSCode extension, Codespace Assistant. Here it is. It lets you select files, copy the file's contents, and then paste those contents back into the file. This is super helpful because it allows you to send code to a large language model, or LLM, for editing. Here is the extension in action. But I still want the functionality of Klein, just without the pay-as-you-go costs. That's where KleinX Mobile comes in. It's like my other KleinX projects, KleinX Local and KleinX Remote, which you can find on my GitHub. The idea is to get Klein's API request into your clipboard. Then, you can paste that request into an LLM that you already have a subscription for. After the LLM processes it, you copy the output and paste it back into KleinX Mobile. This makes coding on mobile both free and a lot easier. And now, time for some LeetCode. Today I did minimum time to repair cars. Spoiler alert. Basically, you're given a list of mechanics and their ranks, and you need to figure out the minimum time it takes for all of them to repair a certain number of cars. The tricky part is that a mechanic with rank can repair cars in r times n squared minutes, and they all work simultaneously. Here's my solution. I used a min heap to keep track of the mechanics and their repair times. First, create a counter for each mechanic. Then create the min_heap array with the initial time, which will be the rank, then rank of mechanic, number of cars fixed, which in Italy is 1, and count of mechanic rank. Then we can heapify it. We keep popping the mechanic with the smallest repair time, decrement the number of cars left to repair, and then push the mechanic back onto the heap with an updated time based on how many cars they've now fixed. We do this until all cars are repaired. The time variable from the last popped mechanic will be the minimum time. The time complexity is O(n) log n, where is n number of cars, because inserting and removing from a heap is log m, where m is number of mechanics. And you have to do it n times for n cars. I also tackled most frequent even element. Spoiler alert again. This one's pretty straightforward. You're given a list of numbers, and you need to find the most frequent even number. If there's a tie, you return the smallest one. And if there are no even numbers, you return -1. Here's my solution. I iterate through the unique numbers in the input list. For each number, I count how many times it appears. If the number is even, I check if its count is higher than the current highest count. If it is, I update the highest count and the res result to the current number. If the count is the same as the highest, I update res with the minimum of the current number and the current res. The time complexity is O(n)², which is not optimal, as the count function within the loop is O(n), and it's within a loop of O(n) unique numbers. That's it for today. If you enjoyed the video, please like, subscribe, and comment. Let me know what you'd like to see me work on next, or if you have any ideas for this series. And if you want to help me continue making videos, you can donate at buymeaboba.com. The link is in the description.